Hi everyone, let's take a look at number 36 on page 421. Use the fact that vector c, the magnitude, square equals to vector c dotted into vector c to prove the cosine law for the triangle shown in the diagram with sides vector a, vector b, and vector c. So step 1, you want to write down a correlation between vectors a, b, and c. So vector c equals to vector b minus vector a. If you look at the diagram, this is going to be vector c as given. A is pointing to the right, so if you draw the opposite vector, that's going to be negative a. And of course, vector b is the same. So you can tell using the triangle law that c equals to negative a plus b or b minus a. Step 2, square both sides. Now when you square both sides, what you're really doing is you're applying the magnitude property, which implies that you can take the magnitude of c square, which equals to the magnitude of b minus a square, or this equals to vector b minus vector a dotted into itself. And again, I'm going to use the arrows to expand this, and there are 4 terms you have to think about as you're expanding it. On the left-hand side, you can just copy vector c, or the magnitude of vector c, square. So again, if you begin with the end in mind, it goes to show this equals to the cosine law. Now, when I look at the right-hand side, what happens is you expand the first arrow, and this will give you vector b dotted into vector b. So b dotted to b. And the second arrow is going to be negative, so 1 times negative 1 is negative 1, so negative b dotted into a. If you look at the bottom arrows, you have negative a dotted to b, so minus a dot b. Last but not least, if you look at negative a dotted into negative a, that's going to be positive a dotted into a. Again, if you go back to the definition, right, using the magnitude property, b dot b is basically the magnitude of b square. And likewise, if you look at that last term, a dot a is the magnitude of a square. If you look at the middle terms, again, because of the commutative law, a dot b is the same as b dot a. So you can rewrite this in the exact same sequence. So what you can do is, instead of writing one in terms of b dot a, the other in terms of a dot b, you can express both of them in terms of a dot b. So I'm going to copy the first one, but reverse the order, minus, again, a dot b, just like that. Now, when I collect like terms, what happens is we have to apply the definition of the dot product again. So what I mean is I can copy the first term as the magnitude of a squared, copy the second term as the magnitude of b squared. Since I have negative 1 minus 1, that's going to be negative 2 a dot b. And by definition, you copy the first term, you copy the second term, but if you look at the last part, a dot b by definition is the magnitude of a times the magnitude of b cosine theta, which is exactly the cosine law. I hope this makes sense.